Hi guys, welcome back to IRIS online classes. Now already we have discussed what is mechanics. In the case of mechanics, we have discussed the different topics, right? So today we'll just look at some of the previous questions that appeared in the case of your SSC CGL as well as SI constables. The first one, a person getting down from a running bus falls forward. Now this is the one which you might have experienced n number of times. That whenever you are moving down from a running bus, or else you might have seen n number of people falling down. Now there in that particular case, when you are trying to get down from a moving bus, the bus is already in motion. So as long as you are standing in a bus, the body, even though it is at rest, the body is at rest with respect to what? With a co-passenger. With a co-passenger, the body is at rest because you are also traveling in the same bus with respect to the co-passenger. But if you see yourself along with that person who is standing outside the bus, or else who is standing on a pavement, or else who is standing on a road, you are in motion, because the person who is standing in the bus stand, he is at rest, but whereas you are moving in a bus. So when you are moving in a bus, your body is also in motion. The moment you step out, right, suddenly if at all you are stopping, which means the feet will come into rest, but not the upper part of the body. The feet will come to rest, because since the feet will be in contact with the ground, the feet will be coming to rest. At that particular point of time, you need to take a couple of steps in the direction of bus. At the same time, keep in mind that you are not traveling in a direction opposite to the bus. Right? So when you are trying to get out from a bus, you need to move in the direction of bus, at least a couple of steps. So if at all the person is not taking that particular couple of steps, he is getting down, standing there itself, then immediately he will fall down, right? So a person getting down from a running bus falls forward. Is it because of inertia of rest? No, because the bus is already in motion. It is due to the inertia of motion. It is due to the inertia of motion that the person is always in motion. Due to inertia of motion, upper part of the body continues to be in motion in forward direction, while the feet will come to rest. The moment when the feet will come to rest, the moment it touches the ground. The moment it touches the ground, the feet will come to rest. So the answer is option number B. Next, friction. What is frictional force? Now already we have seen the case of friction. When you're talking about the case of friction, you talk about the different cases. You talk about static friction, you talk about rolling friction, or else the kinetic friction. You talk about static friction, you talk about rolling friction, you talk about kinetic friction, the fluid friction, the different cases. But in all the terms, in all the cases, when you're talking about the case of frictional force, it is always acting in a direction opposite to the direction of motion. It always acts opposite to the direction of motion. It always tries to resist the motion. It is not allowing the object to move from one point to other point. So it is always trying to resist it. That is the reason why frictional force always acts opposite. Then moving on to the next one. A hole is drilled through the earth along the diameter and a stone is dropped into it. When the stone is at the center of earth, it possesses. Now he is talking something like this. This is the case of earth. From the North Pole to South Pole, you are making a big hole, and the moment you are dropping a stone, the stone is lying at this particular point. At the center of earth, what does this object possess? It possesses only mass. It is not having any weight at that particular point, because at the center of earth, the value of G is equal to 0. When the value of G is equal to 0, weight is also equal to 0. At the same time, already you are saying that G is equal to 0 at the center of earth, right? At the same time, potential energy, this is also equal to 0, because G equal to 0. So at the center of earth, it possesses only mass, because at the center of earth, the value of G is always equal to 0. Next one. The absorption of ink by blotting paper involves a capillary action. Now what is capillary action? We have seen this already. Capillary action, it's nothing but the rise and fall of a liquid. The rise and fall of a liquid, that is what you call it as a capillary tube. Suppose that if at all you are placing a capillary tube in a beaker which is consisting of water. So here in this particular case, the level of water in the capillary tube will be more with respect to the surroundings. But whereas in the case of mercury, Suppose that in this particular beaker, which is consisting of mercury, the moment you place a capillary tube, it will be less than the surroundings. Here in this particular case, it will be more than the surrounding. That particular rise and fall of a liquid is because of blotting paper. That can be blotting paper, tissue paper, sponge, right? The wick of kerosene stove. The wick of kerosene stove, or as the candle, right? The formation of oasis, all those particular things, they based on one particular phenomena called as capillary action, right? The next one. One finds it more difficult to walk on ice than on a concrete road, because in the case of ice, whenever you're walking on ice, the frictional forces between the ice and the feet is less than that between the concrete road, right? Or else, because there is more friction on ice than concrete. So there in that particular case, whenever you are walking on ice, yes, whenever you are walking on ice, it takes more amount of energy, because there in that particular case, certain amount of frictional force, the opposing forces are more in that particular case. That is the reason why it takes more amount of time, or it takes more amount of energy to walk on that particular thing. Next, what is Hooke's law? So when talking about the case of Hooke's law, suppose that this is a metallic wire. Now this particular metallic wire is having a length of something around 10 meters. The moment you add some amount of weight to that, certain amount of weight, maybe around 1 kg, 2 kg or 5 kg, the moment you add certain amount of weight, then in that particular case, after adding weight, the length of this particular wire will be extended. The length of the wire will be extended. Initially it was only 10 meters. But the moment you are adding certain amount of weight, it is increasing up to, suppose that it is increasing up to something around 12 centimeters, if at all. Right, the moment you are adding certain amount of weight, there in that particular case, suppose that if it is the case like this, if the length is becoming something equal to 15 centimeters, right? Here the length is increasing. Why the length is increasing? Because of the addition of some extra weight. So here, according to the Hooke's law, the amount of stress that is being acting on any particular object is always directly proportional to stress. Stress is always directly proportional to strain. Then, in order to double the period of simple pendulum, the time period of a simple pendulum, the time period of a simple pendulum is given by T equal to 2 pi under root L by G. T equal to 2 pi under root L by G. Time as well as length both are directly proportional to one another. So if at all, in order to double the length of a period, in all the cases asking about length, mass, you don't find that. So we need not bother about these two options. So the only thing is that you need to talk about the option A as well as option B. If the length is doubled, then what happens? It becomes 2 pi into under root 2L by G. If it is becoming 2, the length is becoming doubled, then in that particular case, time period will increase only by root 2 times here. Root 2 times. If the length is quadrupled, which means increased by 4 times, in that particular case, the length is becoming root 4L. Root 4L, this is nothing but 2L. So here in this particular case, the length must be quadrupled. If the length is doubled, then the time period will increase only by root 2 times. If the length is quadrupled, then in that particular case, the length increases by 2 times. Next, when a particle is executing simple harmonic motion through the mean position, this particular point word is important. When a particle is executing simple harmonic motion through the mean position. Now this is the case of a particular simple pendulum. You are hanging it like this, suspending it like this. The moment this simple pendulum is allowed to oscillate, this is one particular position, this is another particular point, right? Now this particular point, this is what you call it as the extreme position, or else this is also called as the extreme point. So what is the mean point? This is the mean point. So at the mean point, right, at the mean point, kinetic energy will be always maximum, potential energy will be always equal to 0. If at all you talk about this particular point, at this particular point which are calling it as the extreme position, at the extreme position, kinetic energy will be equal to 0, but potential energy will be equal to maximum, because this is at a certain height from the mean position. That is the reason why, as the height is increasing, kinetic energy decreases, at the same time potential energy increases. When it comes back, kinetic energy keeps on decreasing, kinetic energy keeps on increasing and potential energy keeps on decreasing. That is the reason why at the mean position potential energy is 0, but wherein kinetic energy is maximum, maximum kinetic energy and minimum potential energy. Then, if a small raindrop falls through air, then what happens? Right? So generally, whenever you're having the rain, these particular raindrops, the moment they just keep on moving downwards, what happens to the velocity? The velocity goes on increasing for some time and then it becomes constant. It because of one particular thing called as the resistance of air. It is because of the resistance of air. Initially in the first stage, when you're having the raindrops, you'll be having less amount of air. But the moment it just keeps on advancing, the gases content will just keep on increasing depending upon the different layers of atmosphere. As a result of which, at one particular point, the velocity keeps on increasing, and then finally, after reaching certain point, it becomes constant. Consider the following statements about kinetic energy. So what is kinetic energy? The energy that is possessed because of motion. That is what you call it as kinetic energy. It is given by half mv square. Kinetic energy is given by half mv square. What is the first case? If the mass of the body is made doubled, then its kinetic energy will become double. So here in this particular case, kinetic energy is equal to half into, right? What is doubled? Mass is doubled. So it is 2m into 1 by v square. 2m into 1 by v square. Or else you can even write this one as 2 into half mv square. So here in this particular case, kinetic energy is doubled obviously. So this option is right. Then the next statement, if either velocity of the body is doubled or as the linear momentum is doubled. So if the velocity is doubled, what happens? So kinetic energy equal to half into m into, right? Velocity is doubled. Velocity is doubled in the sense you write this one as 2v whole square. So if at all you are writing this one as 2v whole square, write this one as 1 by 2 into m into 4v square, or else this is 4 into 1 by 2 mv square. So if the velocity is doubled, then the kinetic energy will become 4 times as that of original value. Is it becoming 4 times? Yes. So this statement is also right. This statement is also right. So which statement out of which one is right? Both 1 and 2 are correct in this case. Both 1 and 2 are. If mass is doubled, then it is 1 by 2 into half 1 by 2 into half mv square into 2. Do not cancel these two. Why? Because kinetic energy itself is 1 by 2 half mv square. So even here also 1 by 2 m into 4v square. So do not cancel this. You just take it out outside like this and write this one as half mv square. So it becoming 4 times. So both the statements are correct. Then, which of the following statements is true? G is same. Now this particular thing is something about the acceleration due to gravity. Now when you take the case of Earth, the shape of Earth, it's an oblate shape, or else you call this one as something, the geoid shape. Right? Oblate or else the geoid shape. Now based on this particular thing called as the oblate shape or as the geoid shape, so based on this particular thing called as oblate shape or the geoid shape, Earth is flat at the poles. Now at this particular point it is something flat like this, which means, or else you can even say it is bulging at the poles like this. This is the shape of the Earth as per the geoid shape or as the oblate shape. Now as a result of which, the distance from this particular point to this particular point, this is what you call as the radius. The radius along the equator is more when compared to the radius along the poles. Now you have got one equation, G equal to Gm by r square. Now based on this particular thing, if the radius is increasing, the value of G decreases. right? So along the equator radius is more. If the radius is more along the equator, then what happens to the value of g? It decreases. G is same at all places? No. G is less at Earth's surface than at higher height above? No. G has its maximum value at the equator? No. G is greater at poles than at the equator because of this particular equation, right? Then the depth of seawater increases, right? Now, as just in the case of your seawater, as the depth and at the same time as the salinity increases, salinity is nothing but the salty nature, right? The density of seawater increases because of more amount of salts and minerals which are present in that. So as the depth increases, the presence of salts and minerals also increase, as a result of which the salinity increases. Now that is the reason why we said that whenever you want to swim, swimming is easy in seawater when compared to river water, because seawater is having more density. If the density is more, it tries to push the object in the upward direction. It tries to push the object in upward direction. So that is the reason why swimming is easy in seawater when compared to river water. Why? Because seawater is having more amount of density. More amount of density. So that particular more amount of density is because of only one factor called as depth as well as salinity. Then moving on to the next one. Here, the atmosphere exerts enormous pressure on us, but we do not feel it. Now even at this particular point, whether you are staying in Hyderabad or Mumbai or Vizag or Chennai, wherever you are living in India, right, we are able to do our activities normally. Right? Now we all know that air is having weight, air exerts, air has got certain amount of weight, air exerts certain amount of pressure also, right? But this particular pressure is not experienced by us when we are doing our day-to-day activities. The reason is that the blood also exerts certain amount of pressure in opposite direction, right? So more than that of the atmosphere. So that is the reason why now air is exerting some pressure on the human body. At the same time, the human body is also exerting some equal and opposite pressure. That is the reason why we do not feel the pressure of this one. So this is the answer. Next, it is easier to swim in seawater. Why it is easy to swim in seawater? Because in the case of seawater, density is more. The density of seawater is more. That is the reason why the density of seawater is more. That is the reason why it is easy to swim in case of seawater when compared to river water. So in the case of river water, you don't have salts, you don't have minerals. So that is the reason river water is generally sweet in nature, right? So that particular river water, since it is having less amount of density, it tries to pull the object inwards. That is the reason why you need to apply more amount of pressure to come out of it. So in the case of river water, swimming is difficult. In the case of seawater, swimming is easy, because seawater will try to push the object in the upward direction, right? It is easy to swim in seawater because the density of seawater is high when compared to the case of river water, right? Then we have anything else. Then on a clean glass plate, a drop of water spreads to form a thin layer, whereas a drop of mercury remains almost spherical. Now this is the one which we have experienced in our day-to-day life. Suppose that this is a glass plate or any particular surface. Onto this particular surface, you are placing a drop of water here. At the same time, you are placing a drop of mercury. The moment you have dropped mercury, mercury will always try to remain at the same place. If at all you are dragging mercury, the complete mercury will shift to the next position. But whereas the case of drop of water, if you just drag it and leave it, water will slowly follow, or else it will try to follow another path, right? When you're trying, this is a drop of water. Now this particular drop of water, when you're dragging this in two different directions, right, part of the water will flow like this, part of the water will flow like this. But whereas the case of mercury, when you're trying to drag this in one direction like this here, one direction like this here, it will not follow. Either this follows this one or else this one. Because in the case of mercury, the cohesive forces are very much high, the attractive forces are very much high. The cohesive force of mercury is greater than adhesion forces. That is the reason why mercury will try to move as a complete block. So the reason, in the case of mercury, cohesive forces are very much high in that particular case. Then, why the needle of iron swims on water surface when it is kept gently? Now whenever you're taking a small needle or else an alpin, right? And a small needle, for after cleaning it thoroughly without making sure without any dust particles, when you place that one on the surface of water, it generally tries to float on that one because of one particular force called as surface tension. The moment you are placing that particular needle very gently on the surface of water, then in that particular case the layer of water will try to behave as a stretched membrane. That is the reason why the needle will try to float on it. This is one of the reasons why we say that mosquitoes and flies can easily walk on the surface of water. Because of what? Because of its surface tension. Then hydraulic lift is based on the principle of Pascal's law. Right? Hydraulic lift is based on Pascal's law. What is Pascal's law? Suppose that if you are taking two different surfaces like this. Right, this is the case. Now here this particular thing, this is having larger amount of area, this is having smaller amount of area. Now here suppose that if you are exerting certain amount of pressure at this particular point, right, at smaller area, when you are trying to exert some amount of pressure, some amount of weight at this particular point, the pressure that you are exerting at this particular point, it just keeps on traveling like this. The moment it reaches at this particular point, it just keeps on getting diverse in different directions. It just keeps on getting divided into different directions. So the pressure that you are exerting at one particular point will be spread out equally into all directions. Or else you take the case of a rubber ball or as any particular balloon like structure. Onto this particular surface, you make some holes on this one. You make certain amount of holes on this. Right? Fill this with water. Fill this with water and apply certain amount of pressure on this. The moment you apply certain amount of pressure on this, water will come out from all these particular holes in all the directions with equal amount of speed, indicating that whatever pressure that you are applying at this particular point, it is distributed equally in all directions. That is the reason why water comes out from all the holes with equal amount of speed. That is what you are calling it as Pascal's law. Then, food is cooked faster in pressure cooker because, now we have seen this in the case of atmospheric pressure, right? We know that as the height increases, right, with respect to the place, as height increases, atmospheric pressure decreases. As atmospheric pressure decreases, the boiling point of water decreases. So when the boiling point of water is decreasing, water just boils at 97 or 98 degrees centigrade. As a result of it, cooking will take more amount of time. But here the question is, food is cooked faster in pressure cooker. So in the case of a pressure cooker, you are not allowing any particular gas to escape, any particular air to escape. So there in that particular case, the pressure which is built up in a pressure cooker is continuously increasing. If the pressure is increasing, the temperature of water will also increase. So if the temperature of water is increasing, which means water will start boiling at 100 degrees centigrade. The moment water is boiling at 100 degrees centigrade, cooking will become easy. What are the options? Heat cannot be escaped from the cooker. Steam is hotter than boiling water. Due to high pressure, the boiling point of water is raised. That is the reason why cooking is very easy in the case of pressure cookers. Then, the next one. Fat can be separated from milk in a cream separator because of whatever forces. Centrifugal forces. Cream separator, or else you talk in the case of your washing machine, the mixer, grinder, right? Or in the separation of honey from beehives, the separation of sugar from molasses. All these things are based on one particular thing called as centrifugal force. And this particular centrifugal force, it is a pseudo force which acts equal and opposite to centripetal force. At the same time, this is a force which is directed away from the center. Centrifugal force, a force which is directed away from the center. So this particular fat can be separated from milk or a cream based on centrifugal force. Then, the apparent weight of a body in a lift is less when the weight of a person appears to be less. So whenever a person is moving in a lift, so there in that particular case we have got two different types of weights. One is apparent weight, the other one real weight. This is the original one. Apparent is the one which appears to be. Now suppose that when you are moving on a bike, at a speed of 80 or 100 kilometers per hour or 120, depending upon the bike that you are having, right, you start feeling lighter and lighter. Suppose that if you are on a Splendor, Hero Honda Splendor, on that particular bike, if you are moving at a speed of 60 or 70, you start feeling light. It just appears that the bike is flying in air. Or in the case of your Activa, there in that particular case, the weight of a person appears to be very much less. That is the reason why if suddenly someone comes, it becomes difficult to control the bike. That can be a Splendor, or that can be an Activa, or any particular thing. Suppose that instead of that one, suppose that you are moving on Pulsar, or CBZ, or any particular heavier bikes. So on that particular bikes, when you are moving at a speed of 100 also, right, you don't feel that much difference. So there in that particular case, when you are moving on any particular bike with a greater speed, the weight appears to be less. That particular weight is what you are calling it as apparent weight. So when the body, when the person in a lift is moving upwards, right, now this is the case of a lift. A person is standing here. When the lift is moving upwards, this is the direction of lift. Lift is moving upwards. When the lift is moving upwards, what's the direction of G? G will be acting downwards, which means the gravity is trying to pull the object in the upward direction. The apparent weight of a body in a lift is less when it is less. When the lift is moving upwards, gravity is acting in the body in the downward direction. In that particular case, the weight of a person appears to increase. Instead of that one, suppose that if the lift is moving downwards, gravity is also acting downwards, then in that particular case, the weight of a person, it just appears to be. The weight of a person is not decreasing, it's not increasing. The weight of a person is appearing to increase, or else either it is appearing to decrease. When the lift descends, when the lift starts moving downwards. So this can be the answer, or this can be the answer. When the lift descends. Right? Now we'll see whether it is moving with acceleration or uniform velocity. If at all the object is moving with uniform velocity, in that particular case, the object will not possess any particular change in the acceleration. So here in this particular case, the lift is moving downwards with acceleration. If the lift is moving downwards with uniform velocity, the weight of a person will not change. So here in this case, you have got two options: lift descending downwards. But the thing is that one is moving with acceleration, one is moving with uniform velocity. If it is moving with uniform velocity, the weight will not change. If it is moving with acceleration, the weight appears to be less. That is the reason why when the lift starts coming downwards, as it just keeps on reaching from 10th floor to the ground floor, as the lift keeps on moving downwards, the speed of that, the velocity of that one, it just gradually increases. That is what you call it as acceleration. So these are certain questions which appeared in the case of your previous papers or previous cases. The number of questions that appeared. All these particular questions, they appeared either in the case of your SSC CGL or maybe in the case of your SI or constables. Right? Thank you.